by giving of 2 points and a line in between, and this kind of horizontal line. So horizontal line drawn. The point in the space can be given. Okay, so we have the information of this height, information of the distance of point to the plane, front plane. Okay, so two distances are given. So if you have third one, okay, third point, so we can measure the distance also, another distance. So this distance we have. Okay, so one distance given here, another distance is here. So this one is first one, second one, and third one. So the third one, this point, even though no needed. So by giving these three sizes, you can generate any point in the space. So if we do, if we are able to project a point, so we can generate a line also. So the line consists from 2 points and in two ends, right? So from the 2 points, if you generate 2 points projection on the planes, you can generate the line projections also. So here in this slide, the line projection is shown. Okay, so line A and B, line AB, line AB is given in the space. So point A projection is here. Okay, A dash in the B plane and B dash here. And A is from the top plane projection and B is here. So by orthogonal projection, so you can see here in the frontal plane V plane, horizontal is H plane, and profile is W plane. The line can be done like this way. Okay, so A B dash, A double dash, B double dash, and A B. So all other points can be generated in between the line. For example, point D is given somewhere here. That lies in the AB. So the note is the points which lies on the line in the space. That points will lie on in their projections, in every projection. Okay, so in their projections should lie this point. For example, big D. So D point lies somewhere in between point A and point B. Okay, so that point should lie on the projections, in their projections also. So somewhere in the projection. So projection from in the frontal projection, V projection should lie here, and in the D, in the horizontal H projection also lie not here. Okay, so it should lie in between A B. In their projections also it should lie. Okay, so how it looks like in the computer in 3D. So here our coordinate system, right? Okay, so the upper one is Z, and this one is X, and that one is Y. So I hide this. So you see point A and point B is given, and the line is given. So the blue line is given. Blue line is given in the space. So if you project it to the blue side, so we will get A dash and B dash line. So this one. Okay, so we'll get this one. And if you project it on the top plane, the yellow plane, okay, so that calls H plane, horizontal plane. So we will get A B line. And then that is a right plane. So if you project it to the 90 degree, okay, so the looking of 90 degree to the purple color, so we'll generate the projection of A2 dash and B2 dashes. Okay, so that is a projections of line A and B. Okay, into the orthographic projections. So So now let's see how it looked like in projections. So you see, so one line in the plane V, one line in a plane H, and one line plane W. So this line, that line here, and another line. So by changing these slopes, so you can change the position in the 3D space. Okay, so any line with any slope can be given with using these 3 lines. Okay, so 3 lines in 3 planes. So there is an example of orthogonal projection of the part. Kind of prismatic shape. Prism shape is given, and on the left hand side. Okay, so this shape is given, but how to? Okay, that is given as a 3D kind of view. Okay, so that is we call this one isometric view. So in isometric view is given like this 3D, but to draw this one is not easy. So but Monge method or orthographic or orthogonal projection is this one on the right hand side. Okay, so that is isometric one. Isometric view is similar to the 3D. Sorry. And right hand side one, orthographic or orthogonal, or are same. Okay, so all are same. Orthographic or orthogonal are same thing. Orthographic projection. That's a 2D. Okay, 2D. So right hand side is to the orthographic projection. So if you see to the right hand side, there is a all characters are small character. Right hand side is big characters. Okay, so whenever if you want to create orthogonal projection, so this kind of thing you will get in examination. Okay, so you will be given kind of isometric view or 3D kind of view with size, okay, with dimensions, with every sizes are written there. So but on your page, on your sheet, you have to draw orthographic projection of it. Okay, orthographic projection of that 3D object, and you need to draw a line, this horizontal line and vertical line, and one side, okay, so front side, so it will be given as a with using an arrow. If there are no arrow, you have to decide yourself and draw it. But before to drawing it, so you have to define a points. Okay, so point B, point A, point C, and point another point here, another point there. Okay, so and then you measure the distance between A and B and A and so this point and between this, and then you have to draw it. Okay, so then in descriptive geometry, these given points can be given as a projection, right? So the projection should be small characters. So and everything in the V plane should be with one dash. Okay, so everything in the plane H, so should be without any dash. Okay, so that's why A, B, D, you see small characters, and there are no dash. And in plane W, it should be some C2 dashes or D2 dashes. Everything with 2 dashes. Okay, so and so you draw this one, right? How it looks like from the top, from the top view, from the top side, you will see this kind of picture. Okay, so this kind of shape, and then you have to draw it, and the points A and B lies in the same line, so that's why A equal to the B here. And if you see from the front side, from this side, so right side, C and D lies in one line, so that's why C dash and D dash are equal to each other. So A is here and B is here, and from the top is this. Okay, so C is here and D is behind here, that is here. So whatever, if you see from the red side, so you have to draw here, and whatever you see on the top here, you will see this and this. So you have to draw here. Whatever you see from this side, say triangle shape, like, or just let's change the color, another color. So let's make another. So everything in red side should appear in the red side. Okay, so in the V side, V plane side. Everything yellow should appear here in the H plane. And if you have the W plane, so everything green side should appear here. Okay, so that's a O, and that's a Z, and that's a Y, that's also Y. Okay, so if you see from that side behind, so everything from there, so what color? The magenta. From that side should appear in here. Okay, so somewhere here on the left hand side of the red thing. Okay, so that's a way how it looks like in the 3D to imagine your imagination. So I did a this one. Okay, so this part is given, okay, in the 3D space, kind of a stairs, and red thing. Okay, so red thing is projected, same like in the blue side, can be projected something like this. Okay, so and this side, this blue side, this stair side, appear like this onto the purple plane. That is W plane or right plane. We call right plane or W profile plane, actually profile plane. And the yellow thing, yellow side to top side, should be projected to the top plane or horizontal plane, H plane, like this way. So if you see in 3 view or orthographic view, orthogonal view, so we'll have this kind of shapes. Okay, so the shape will be here, the red one, and the bottom one. Okay, so this one is in the top, so that calls the front view. So you see the front view, and also we call F, right, because of front, that is F, and the frontal F. And a top view, you will see this kind of two square or two rectangles. That is a H plane. So top plane or H plane, horizontal plane. And the third one is the right plane or W plane or profile. Profile. Profile, that is a front. And that is a H one is horizontal. Okay, so this is a isometric. That is isometric view. So in the examination, you'll be given this kind of thing, isometric view shape, and you have to draw yourself with just instrument. Okay, so there are no computer, no software. Okay, on the page, on the two-dimensional page, this A3 sheet. So you have to draw the front view and horizontal view and the profile view, and using sizes. Okay, so you have to measure is using a ruler, and you have to draw with pencil. And the note is the edge. Okay, so edge should be projected. Okay, so correctly projected. So this point should be projected, lies in one line. Do not draw somewhere here. Okay, so it should be in one line with other projections. So that means a projection. Okay, so this point and that point lies should lie with same level, same line. Okay, all should be same. And the distance of this is equal to distance of that. Okay, so distance of this is equal to distance of this. So everything should match with each other. Okay, so that's a projection rule. If you do wrongly, so that you'll be, it will be decided as you did wrong. Okay, so if the line is with like this, okay, so the line AB is given in the space, and the line is perpendicular to plane H. Okay, so to the top plane, it's a perpendicular. Projection on the V plane will be like this. Okay, straight line like this. But if you open, okay, so H plane to the dawn, that will be in the one point. Okay, so because A and B is lies in same position. Okay, same point. So A equal to B, A equal to B. So if you see this kind of notation, so that means the line is the perpendicular to the H. Okay. So that will be projected to the V plane. Okay, so the profile plane. And if the line is perpendicular to the V plane, so that will be something like this. Okay, so if you see from this side, so you will see only one point. C dash and D dash are equal. And from the top side, you see, you will see a line, CD line like this. So that's this one in the reality. So that is in the 3D, and that is a orthographic projection. That's a projection. That's a 3D. So that's a 3D or isometric view. So that's a projection, orthographic projection. Orthographic projection. So horizontal straight line and a point are given. Okay, so the line is given AB. Okay, so AB line is given, and point K is given. So capital letters, you see. So here you can see the projection of it. So on the plane H, okay, so that's the parallel to the H. So that's why the line is straight like this. And in vertical, in profile projection, also that is a straight. And the point, you see, given like K dash, K double dash, and K itself. So the rule is, if the point in the 3D space, if in the 3D space in real life, if the point doesn't belong to the line, in their projection, some of their projection will not lie on the projected line. Okay, so if the K point, you see, it doesn't lie in one, okay, in reality, in real line with capital character. So, but in their projection, it lies, because if you see from the top, you will see it lies in some of the projections, but some of them is not, because the height of the point K is higher than position of AB. Okay, so that means if in any projection it doesn't lies, so that means that point doesn't lie in real 3D space. Okay, understood? Okay, so here another projection. So this line is parallel to the horizontal plane, this one. So these two lines are parallel to the horizontal, and the parallel to the frontal projection, frontal straight line, we call frontal straight line. That is a horizontal straight line if the line is parallel to the horizontal plane. If the line is parallel to the vertical, okay, frontal plane, V plane, so we call frontal straight line. Okay, so it's like this. So we project it to the V plane with slope. But if you see from the top, that is parallel to the V plane, so that's why it makes like this. Okay, parallel line to the XO line. And from the side also, if you see from this side to the W plane side, so you will see again the straight line like this. So because of that is a parallel, the line is parallel to the V plane, so V plane. So that's why it looks like this. Okay, so only one slope. It has only one slope. And again, for the M doesn't belong. So M point in the space is not belong to CD line. So that's why in their projection, you see, it doesn't lie in their projected line also. So if the line is parallel to the W plane, that is profile plane, it looks like as a projection. Okay, orthographic projection. It looks like this. Okay, so the W is here, so that's why it's a parallel to the E dash F dash, and same like E and F line is parallel to the OY and OYH plane. Only one side is it has a slope, so that's why we call profile straight line. Okay, so if you have 3 points, what will happen if you if the 3 points are given in the space? So 3 points are given. So normally you will have a line, the line OX, and in the reality we have something like this. Three points are given. 1 point, okay, so that is X, and O is here. So this distance is from the O. You have to measure the distance from the O, the first one, and put that distance here. Find the point, and then make parallel line to the OY point, OY line, and then put that second distance to here, and make a parallel line to the OZ, and then define a point A. Okay, so point A is given like this. Point B can be given like okay, so measure that distance, the third one, and that is less than first point, so that's why you can make a this line. And then B is higher position than A, so point B is here. And then point C is not far from O point, but smaller. So point C is here. So in the space, if the A point and B capital and C capital points are given, so that's in the 3D space. In the 2D space or orthographic projection, orthogonal projection, it will be something like this. Okay, so on the top of OX, A dash, B dash, and C dash are given, and in the bottom, A, B, C small So it's given, and in between there will be a line. It might be continuous line or dash line. So that means 3 points are given. So if in examination is asked like, okay, so how many points you can see? So you have to answer only 3 points, 3 different okay, discrete points are given. Okay, so not 6 points. Okay, so that is a 3 points. So 3 points in 2 projection planes makes a 6 projections. Okay, but that will generate only 3 points. Okay. So if you connect A and B, so you can generate one line and 1 point is given, are given. So 2 parallel lines can be given like this. So this is in 3D space. So this one, because capital characters. Okay, so A, B, big, C, D, capital, big. Okay, so those are in 3D. So their projection are this. Those are projection. Those are projections that is in 3D space. And that is orthographic or orthogonal projection. Okay, so that's orthographic projection. Orthographic projection. So we have OX here, and on the top, that's the frontal plane, front plane. We have 2 lines, and the bottom is horizontal plane, top plane, right? So that is AB and CD without any dashes, but they are lies on same line. Okay, so same straight line, and so if the lines are parallel in the 3D space, okay, in the 3D space, these A, B, and C, D are parallel. Okay, so these are parallel. So if in the 3D space the lines are parallel, on their projections also will be a parallel. Okay, so on the both or 3 projections they will be a parallel. Okay? In every projections they will be parallel. So here they are parallel, and here also are parallel. If one of them are not parallel, so then in the 3D space all those lines are not parallel. Okay, so that's a rule. So intersection. So in the 3D space, these intersected lines are given. These 2 intersected lines are given. That's a projection. That's a projection. So the rule is, again, if the lines are intersected with each other in the 3D space, so in their projections also they will intersect. Okay. If any of the projections they are not intersected, that means in the 3D space those lines are not projected. Okay, understood? Okay, I will repeat it. If the line in the 3D space, if the 2 lines in the 3D space, so these lines are intersected with each other, and if they generate kind of single point, K point, so in their projections, they also intersect. If okay, so here in their projections, in every projection they will intersect. If the lines are not intersected in any projection, so that means in the 3D, those are not projected. Okay, so now the latest slides. So the traces of the plane. Planes also can be given in the orthogonal projection, how it could be. On the right hand side, you can see the plane is given. Okay, so plane P is given, and this is W plane and H plane and W plane and V plane. Okay, so V, W, and H plane, those are space planes, and then this P plane is given. So how to show this one in the page, two-dimensional page? OX is given like this, and then the traces. Okay, so the plane intersects actually the plane V, H, and W. So by these called traces. Okay, so by intersection lines of the planes can be given the plane. Okay, so by the traces of it, and the point of px, so because of it's intersecting a x axis, so that's why px. That intersects pz here, so that's why the point can be, this one is pz, and that is can be py point. But the line itself, okay, intersection line pv, so because of that is intersecting v plane and h plane, so that is ph. Okay, so by giving this kind of traces, so you can define or you can give the planes which is inside a 3D space. So here the different plane positions. So the plane like this given, so that will parallel, the one side is a parallel to the OZ, but in the horizontal side there it has a slope, so that's why horizontal projection plane. So it will be given on the right hand side like this. So this one is front projection plane, because of in frontal projection, frontal plane, V plane, it has a slope, so that's why we call front projection plane. But this side is parallel to the OY, so that's why this is a straight line here. And if you have a plane like this way in the 3D space, only one side, only W plane, it has a slope, but all others there are no slopes, so that's why it's straight like these two lines. The third one, it has a slope. So bisecting plane, so it's dividing the space into the two parts, so that's why we call like bisecting plane, this one. So if the plane is parallel to the H plane, we call a parallel okay, projection of the level. Okay, so the level, like the floor level, like the first floor, second floor, something like horizontal, parallel to the horizontal plane. Okay, plane of level. Okay, so how it looks like in a in reality. So like this. Okay, so the green plane is given, and that cuts, okay, intersects the blue one and yellow one and purple one. So by giving a traces, so these traces, so the intersection lines, we can give a the plane in the 3D, in a 2D. So something like this, you see. So the trees, okay, so this line and that line, and so like this. So the line here and line here and then line here. Okay, so by the giving of this kind of traces, the plane can be given.
Yes, if we have to demonstrate this into 2 dimensions, its lines must be the same in 2 dimensions.
Okay, if you want to make a okay, so we have a 3D now, right? 3D software.
Yes.
So
Yes.
if we just imagine if we do not have a 3D software, so then how to represent in two-dimensional page, right? So you need to draw two lines like this, right? That represents 3 planes. So here the H plane. So H plane, okay, H plane. Here the V plane, and here the W plane. right? So the traces, your traces will be something like this. Okay. So plane is here like this, like that. So and then this distance should be equal to this one. So something like this. So if you have this line, so that means the green plane is given.
Okay, thank you. My question was that I mean that the lines should be equal or not?
It might be different. It might be different, but only the equal thing is only this. So I will show now. So only this one. So this distance and this distance should be equal. The lines, it might be different. Okay, so something like the different positioned. So that means the plane is positioned differently. So okay, so it might be different, any different sizes of the plane. Okay, plane location. It not must it not be like this must. It never must. Okay, so the sizes, this size, the point location, this point, that point might be different to represent different planes. Might be two planes also. If you have two planes, so then you will have two traces. So one plane is like this, and another plane. It might be like here, another plane. So, but you have to write the nodes. Okay, so the intersection points, intersection point here, and intersection point, and here. So that is a PV. Plane PV and PX projection, that is, this one is PW, and you call this one like PQ plane, like QV, and that's a QW, and this one QH. About the points, points, that is a QX, QZ, sorry, QZ, and that's a point QX, that's QY, and that is also QY. For the P also similar. Okay, so intersecting axis. Okay, so because this one is x-axis, that is z-axis, and that is y, and that's also y. So same like this. Okay, so it might be differently plane. Like if you have a plane, the parallel to the right plane, but differently located something in the something like this. So I will show you in the presentation.
Professor.
So like this, like that one. So front projection here, the not parallel but parallel to the edge, or parallel to the two planes, but not parallel to the profile projection. Traces. So traces can be given as the traces which is intersects the projection planes. Like for example, the green plane is given in the space. So how to represent this one in two-dimensional space? So actually this green space is intersects here. So intersection points are this here. Okay, so intersection lines, that will create the lines here and there, and in the top plane. Okay, so that's yellow one is H plane, blue one is V plane, front plane, and profile plane is W, the purple one. So then when we open the planes and represent as a orthographic view, so the traces remains, and that will look like something like this. So so this is an axis. So this is 0, that's z axis, that's y, that's y. So plane trace will remain like this. And name of the plane, okay, so P plane, so that's why that will be P in a V plane, P in W plane, P trace. So every time that is a capital character, so that is a H plane. Okay, so plane names, that is horizontal plane, that is front plane, V, and W is profile plane. So name of the planes, let's write the name of the planes also. That is top plane. So another name is horizontal plane, and this one is frontal, and this one is profile for the object's left hand side. Okay, so left. Okay, so by giving these traces, we can define a plane which might not parallel to the projection planes. In case of the planes are given, P plane is parallel, so one of the planes, so that will be something like this. So let's draw it. In case of it has a slope. Okay, so plane given P plane has a some kind of can be a slope, have a slope or cutting with a slope of in top plane, in horizontal projection plane. Okay, so horizontal plane, so that calls horizontal projection plane. Like if you see from the top, that will make like this line in the top plane, and in the front plane that will make like this trace, the vertical trace, and in a profile plane also makes like this trace. Okay, so can you imagine that? So that is X, this is 0, that's Y, that's Z. So the plane looks like something like this. So that's an axis. So P plane is given something like this way. Okay, so that's x-axis, that's y-axis, That's z-axis. So here is 0. Okay, so when you open this box, okay, so this 3D space into the 2D, so you will have these traces. Okay, so here this one is this one, and that side traces this one, and the top side traces this one. Okay, so this call horizontal projection plane, because this one is horizontal plane, right? So H plane, so it has a kind of a slope. It's not a parallel, or it's not a cut. Okay, it's not a perpendicular to this horizontal plane. So it's making a trace. Okay, so it's making a trace. Trace is not parallel and not perpendicular in this xy plane, so that's why, or horizontal plane. So that's why we call this one horizontal projection plane. So the projections can be seen in xy plane, so or H plane. Okay, horizontal projection plane. In case of that, will make a kind of in the frontal place, something like that, slope. So that will be like this slope, but the other side is like this, parallel to OY, and this side also parallel to OY. This is X, Z, Y, Y. That is X, H plane, and that's O. So this is a PH plane trace, and PV and PW trace. This is PW, PV, and PH. So how is given in 3D? So how you imagine in this 3D? So this is a 3D space. It has a slope. And here the parallel is OY axis, and here also that's a parallel. So that's a Z axis, that's Y axis, that's X axis, that's 0, and plane is given here. So that's P plane, and traces are this one. Okay, so this one is PW, that one is PV, and this one is PH. Okay, so this called frontal projection. Okay, so that's because of it makes a slope in a frontal plane. Frontal projection plane. that one horizontal projection plane. Okay, so similar to the other projections, other projection planes, that might be profile projection plane. So let's see how it looks like. So profile projection is this one. So that's why the slope is here, and traces on V plane and H plane is like this. X, Y, Y, Z, P, V, P, W, and P, H. That's H plane, that's V plane, that's W plane. Okay, so the notice the distance of this one every time should be equal to distance of this. Okay, as I told you, the y are equal, so we open this one in the box this way from the box. So that is a profile projection, how it looks like in 3D space. So say this one is 3D space. So it has a slope here. So this is given P plane. And okay, so P plane is this, but this one is a trace. Okay, so P W. So this is W plane, and this one is V plane. Okay, so front plane, and that is horizontal plane. So that's why this one is P H, and that one is P V. That is X, that is Y, that is Z axis. Okay, so so this calls profile projection. Profile projection plane. Okay, so there are another type of projections possible. So projection of level. So how it looks like. So it looks like this. That is X, Y, Y, Z, 0. So that is P, V, and P, W. It's kind of parallel plane, which is parallel to the horizontal plane. Okay, so that's why it goes parallel. Okay, so projection of the level. So that is in the 3D space looks like this. So that is H plane. So that is given P plane, so which is parallel to the H plane. Okay, so that's X, Y, and Z. So as I told you, this calls projection of lever. Okay. So those are planes, and one more plane we call bisecting plane. So it's bisecting, it's making dividing a two equal half of this one quarter of the space. So for example, if the space is given like this, this is X, Z, Y, is cutting bisecting of Z, Y, okay, Y or Z plane to the two half. So an orthographic view that looks like this. Okay, so we did here the line same like OX because it's bisecting only this half. Okay, so this quarter, the 3D space. Okay, so one side, so other side is stopping. Okay, so as I told you, the 3D space consists by the Monge method, it consists from 4 quarters, like this. So 4 quarters. So 1 quarter is this area. Okay, so first one, on behind the second quadrant, quarter or quadrant. The third one is here, and fourth one. So this is third one. So 0 is here. So that is X and Y. Okay, Z. Okay, so the that is a Y. Okay, so we set okay, so if you say 0 is here and x is here and y is here, we set inside here everything here, so in first quadrant, and this is the side of the negative side of the from the 0, the second one. Okay, so that's why this side is 0, so minus y, so minus y. So that's why is cutting only the positive side. So that's why we have slope here, and another side is given as no cutting, just same as OX. Okay, so OX. So like this here, and so this calls a bisecting plane. So it cuts only one quadrant or 1/4 of the 3D space. Okay, so today we are talking about how to give a traces. Okay, so how to give a traces or without traces, how to give a plane without giving only traces. So there is a ways of plane definition besides on the traces. It might be given as these ways. Okay, so it might be given with three points. So if the 3 points are given, you can generate a plane. Here you can see the first one. So 3 points are given. So okay, A, B, C points, the projections. Okay, projections on the top plane, H plane, and projection in the V plane. So by as a result of this, so if you use the 3 points, you can generate a plane with using this. Okay, and create a plane. So another way to create a plane is the line, one line and one point. Okay, so by using this A and B points, is generated the one line and one point. Okay, so 1 point is given. Okay, so with using two A B points, it was generated a line. So by using one line and one point, also we can create a plane. Okay, so plane can be given such a way. And another way is the third one is crossed lines. Okay, so 2 lines are given. So A, B lines and C, B, C line. Okay, so B, C line, but the B point is intersection point of 2 lines. Okay, so with using 2 intersected lines also can give a plane. Another way is the fourth way is 2 parallel lines. Okay, so by giving of 2 parallel lines, we can generate a plane. And also the triangle. So by using a triangle and we shape. Okay, so one triangle is given in the space, so we can define a plane by using this triangle. So any two-dimensional essentials like triangle, rectangle, the plane shape, so we can generate a plane because those shapes are drawn in the plane actually. So that's why that will define a plane also. And the last one is same like our previous example, by giving a traces, by showing a traces which has a resultant of intersection of projection planes and a given P plane. So that will create a traces. So by the traces that will be defined any plane. Okay, so here you can see the traces of the line. Okay, so how could be a trace of the line? So if you see the line A and B, capital characters here. A point and B point. So A and B point is given. So this line is given in the space. So what will be traces of this one? Intersection with projection planes, how it would be. So if you continue this line, so that will cut somewhere in N point, cuts V plane. Okay, so cuts V plane, and if you continue this side, okay, so this side, so that will make a point, M point. Okay, M point is in the H plane. So how to do this one in the 2D space? So we did in the 3. If you have this kind of 3D, so you can easily define, but how to do this one correctly in the two-dimensional space, two-dimensional page. Okay, so the way is in the 3D. Let's understand first in the 3D. So we continue here up to here, and that cuts, right? So that cutting place also similar position with these projections. Okay, so A and B, capital A and B, that is given in the space, and projection of this in the V plane, in the front plane, is A dash and B dash. Okay, so projection, and its projection in the H plane, the horizontal plane, that is A and B equal. Okay, so and the trace, okay, so traces traces points, and is same position with if you continue the line, okay, the projection AB until it cuts, okay, it intersects OX axis, so you will get point N. That point is similar, okay, similar position with the space, okay, the space point N, okay, point in the space big capital N, that is trace of this line, okay. So same thing. This side also similar. So if you continue to the OX, this AB projection, AB dash projection, so you will get M dash, and that is same position with this side, okay, 3D trace, okay, 3D point M traces, so same. So the way is in the two-dimensional space, same like this. Okay, so we are making a line and finding a N point on the OX and M dash point in the OX, and we are making a line until that intersects this AB projection. So we can find M, and this side we will make a line here and finding a intersection point N dash. So that N dash and M is projections of traces. Okay, so projection of the trace points, same point. So you can find at that distance and that distance. Okay, so that distance is this one. This distance is this one. So we can find the positions of this M point and N point in this 3D space by using only two-dimensional space. Okay, so more time. So we have a slope, right? So continue that slope until that will cut OX. So let's see it in the blackboard. So the line is given like this. So continue it until that cuts OX, find this point, and continue this one, fine, this is n. Okay, so points are given like a dash, b dash, this a, b, so that is n dash, and continue this one until that cuts ox. Okay, so that is m point, and continue this one, it cuts until m dash. So this one, this point and that point is traces of this AB line in the space. Okay, so the way is like that. Okay, so everything on the top comes with dashes. Okay, dash, dash. Everything on the bottom in H plane, it comes without any dash. Okay, so traces of the line can be found with that way. So construction of plane traces, if the plane is given with two intersected lines, as we told you that the planes can be given with such many ways. So it's given with two intersected lines. The plane is given in two intersected lines. How to find its traces, the traces generated on a projection planes. So it's given in this slide. Okay, so the question is these two intersected lines A, B, and D, C lines are given. A, B, and D, C lines are given, and how to find these yellow traces. Okay, so P, V, P, W, and P, H. How to find it? So we don't have this. Okay, so we have only this two-dimensional space, and the two intersected lines are this one, the green one and blue one. So we have to find these yellow things. Okay, so yellow traces, plane traces. So we have to find PV, PH, and PW. How to find it? How to find it? So with the same way, we have to first we have to find traces. Okay, so the line traces, which line? A, B. Okay, the green line traces. So we have to find two intersected point of that lines, that line. Okay, so 2 points that line, and M1 and N1, and the blue lines traces, that is N2 and M2. So we have to find the traces of the blue line. Those are N2 and M2. So with using that four traces, 4 points, we can generate this the plane traces. Okay, so let's start from the beginning and construct. Okay, so two axes are given, and two lines are given. So one green, one is blue. So one green line projection is given in V plane, so the green one, and projection is in H plane is this one. So the blue lines projection is here, and in H projection in here. Okay, so that's X, that is Z, that's Y. So how we do? Let's use red color. So we'll continue the slope. Okay, so let's write down the point names. So point A dash and B dash, and that's A, B, that is a D, C, C, and that point is D. So we'll draw like, say, in this legend. Okay, so D. And how to do now? We have to extend it until that reach X point. Okay, so OX line. Then that makes a point M, M1 dash. Okay, so here, and also extend this one AB projection until that reach OX axis. So it's here. So that makes a point N1. Okay, so and make this side also, extend it, and then from M1 dash make a like this line, vertical line, so that will make a M1 point. So that's M1 dash, so that's M1 itself, M1 point, and we'll extend this side also. So from N1 you can create N1 dash. Okay, so now we have 4 points. Okay, so N1 dash and M1 dash and M1 and N1. So we have only 1 point. Okay, so two three points. So 2 traces. So that 2 traces belongs for the green line. Okay, so for single line. Okay, for one line makes 2 traces. So first trace is this one. So let's make yellow this one. First trace point, second trace point. So we need to make same thing for blue line. Okay, so extend it until it cross with OX axis, and extend this side and extend another side. From this point, make a vertical line like this. Extend another side. From this point, make vertical line until that will meet C dash D dash line. So then make a point. So this one is N2 dash. So this is N1 dash. So that is N2 dash. And then this one is M2. So that is M1. That is M2. So now we have two more points. So that is, this is freeze point for CD line, and then we have to make a line is using N1 dash and N2 dash and M2 and M1. Okay, so passing through that points. So let's make different color. So let's make a yellow or orange color. So then we measure this distance and put there. Okay, so to the OY axis, so it will be somewhere here. Then we can make another side of the trees like this. So we can write it down. So that is PW, and this one is PV trees, and that one is PH trees. Okay, so this is a way of generation or construction of plane traces when the plane is given like two intersected points. So with using two intersected points, we create a plane, and so that plane create the traces when it cuts or intersects projection planes like V plane and H plane and W plane. Okay. So another thing is projection of right angle. So there is a theorem: a projection of a right angle with one parallel leg to any projection plane will be also right projected angle. Okay. If the right angle is given in the space, and if the one leg, one side, okay, so this one side is parallel to the any projection plane, for example P plane. Okay, so it's a parallel to the P, so that's why angle of projection, okay, projection on that plane also will be a right angle. Okay, so even though so another leg, it might not be parallel. For example, key E line is not parallel to the P, but only one leg, ED leg, is parallel to the P. The one leg is enough to be a to have a right angle. Okay, so in the space it has a 90 degree. So but if you project it, the projection, in the projection also, that angle keeps that angle remains 90 degree. Okay, so it's a right angle. So that's a theorem. Okay, so only one leg is enough to be a right angle. Okay, so one leg should be parallel with given projection plane. So this thing we can see here. Okay, in one projection it's a 90 degree, but in another projection, so if you see from this side, if you project it to this plane, so you will have something like this. Okay, so one leg is ED is here and KE is here, like this. So this one. So